Step into tech lately, and the word transformer is everywhere you look. This model now powers everything from ChatGPT to image generators and code assistants. Transformers have been quietly running the show since 2017, yet everyone suddenly treats them like a brand new breakthrough. What actually makes this architecture so powerful that it just exploded overnight? We cut the fluff for the straight truth, no corporate jargon. The transformer is a neural network built to swallow anything that comes in a line. It reads words, audio, signals, DNA sequences, or stock prices one after another. What makes it special isn't some magic formula. It comes down to one architectural idea. Every element in the sequence talks to every other element all at once. Before transformers, models like RNNs and LSTMs chewed through data one token at a time. They read a sentence word by word, and by the time they hit the end, they had already forgotten the beginning. Transformers completely ditch that limitation. They swallow the entire sequence at once and instantly map how every single piece connects to every other piece. The whole architecture dropped in 2017 inside a Google Brain paper called "Attention is All You Need." It is a famously brief 14 pages. It sits comfortably among the most influential AI papers ever written. At its core, a transformer splits into two main engines called the encoder and the decoder. You will not always see both in one model, since GPT-style networks run decoder only while BERT-style networks run encoder only. But learning how they both work gives you the full picture. The encoder grabs your raw input sequence and forges it into a much richer representation. It achieves this entirely through layers of self-attention, which stands as the signature move of the entire architecture. Self-attention makes every word scan the entire sentence to judge its neighbors. Each token asks one clear question: how much does that other word actually matter to understanding me? When you read that the animal didn't cross the street because it was too tired, your brain instantly locks it back to the animal. Self-attention does the exact same thing. It spots the reference and stitches it together without missing a beat. The decoder grabs those representations and turns them into a final output. In translation, it reads the encoded source sentence and builds the target language one word at a time. Generation models like GPT run on a decoder that takes your prompt and predicts the next word, then the next, all auto-regressively. Cross-attention lives right between the encoder and decoder. It lets the decoder scan the encoder's output at every step. That makes it the bridge between understanding and generating. The magic sauce behind modern AI boils down to two concepts called self-attention and multi-head attention. This pairing turns raw text into real understanding. Multi-head attention runs several parallel mechanisms at once. Each one learns a different relationship, while a dedicated head captures grammatical structure. Self-attention is exactly what makes transformers fast and effective. The model abandons sequential processing and computes attention scores for every token pair simultaneously. Other heads track semantic references, while a few just notice positional patterns. The result is a model that processes entire documents in parallel during training. It captures long-range dependencies that previous architectures struggled with. This is the question nobody asks but absolutely should. The name transformer is wildly misleading because the model never reshapes data from one format into another like you might expect. It transforms representation and changes everything. Every transformer layer takes raw number token embeddings and completely reshapes them. Watch the data shift into increasingly abstract context-aware representations. After enough layers, a token like bank stops being just a number. It actually knows whether you mean a river or a financial bank by reading the full sequence. The transformation is a journey from flat context, independent embeddings to rich context, aware representations that capture meaning. This shift unlocks true contextual understanding. When you hear transformer in generative AI, it always means a decoder. Only transformer trained on massive text corpora. Think GPT and Claude and Gemini alongside the open-source LLMA lineup. These architectures power the chatbots shaping our daily workflows. These two powerhouses actually share the exact same genetic blueprint. It runs on a decoder-only architecture that drops the encoder and focuses purely on generation. The model learns via autoregressive training by predicting the next token from what came before. It then runs massive pre-training on trillions of tokens from diverse sources. Fine-tuning sharpens a broad model by training it on much narrower datasets. We feed it instruction-tuned examples and reinforcement learning from human feedback. The key insight hits when a transformer predicts the next token on a broad enough corpus. It stops memorizing and actually understands language. It naturally picks up reasoning patterns and coding conventions. These models absorb even basic world knowledge on their own. That emergent capability is what makes generative transformers so useful for tasks that go way beyond simple text completion. GPT stands for Generative Pre-trained Transformer, and the name tells you exactly how it works. The transformer is the core architecture we just covered. Pre-trained means it learned broad language patterns from a massive general library of books, websites, and code. Generative means it was built to create entirely new text. It was never designed to simply classify or analyze what already exists. GPT models are the absolute workhorse of modern AI. Every chatbot, every coding assistant, and every content tool you use likely runs on this exact architecture. The specific model names shift between GPT-3, GPT-4, GPT-4o, Claude, Gemini, LLM, and Mistral, but the core engine never changes. This is the absolute broadest category. Every language model built on a transformer architecture lives here. It covers three main families. Encoder-only models like BERT and RoBERT excel at understanding classification and analysis. Decoder-only systems such as GPT, LLM, and Claude dominate generation and conversation. Encoder-decoder architectures like T5 and BART handle tasks that need both. You see them handling summarization and translation with ease. When experts say transformer-based language model, they are just being precise about the architecture. It serves as the master label for the entire family. Real-time translation and creative writing alongside code generation and image understanding would all collapse without a new approach. The transformer changed everything by processing information in parallel instead of step by step. These models did not just tweak older systems. They unlocked entirely new capabilities by relating massive information streams simultaneously. Experts assumed recurrent networks would always win. A simple attention mechanism quietly overtook them everywhere, and the industry never recovered from the surprise. The ripple effects are still unfolding today. What is the core architectural innovation of the transformer? It hides in plain sight at the center of the model. The answer is self-attention. It lets every sequence element lock onto every other element at once and completely replaces slow, step-by-step computation with lightning-fast parallel processing. Decoder only. Transformers power every major generative AI model on the planet, including GPT. They became the standard because they generate text one token at a time without ever looking back. Decoder-only models generate text autoregressively, one token at a time, and scale effortlessly. They drop the encoder entirely since generation never needs a separate understanding pass. The decoder handles it all. It handles both with zero friction. You get everything you need in one clean workflow. The model starts by consuming a massive general-purpose text corpus to absorb broad language patterns and world knowledge. Then it sharpens that foundation with fine-tuning on specific tasks or direct instructions. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day, and tap the video on screen to keep going. See you in the next one.